Okay, thank you everybody for joining. I think it will be an exciting session for us today. I want to talk about digital manufacturing today. I think it's an area that we have really not looked at. It's an area with so much potentials. And I will be sharing my screen in a bit. Good. This is one growing session, or one growing area that I think for us in Imagine Africa that we should pay very close attention to and understand them closely. So I've titled it The Factory of the Future, that's digital manufacturing. As much as I know that it's the factory of today, so it's one of the reasons I'm doing the session is to waken the spirits within us, that we could do so much with digitalization of our processes, our systems, especially how this could help us become more efficient, make our processing more efficient. When we think about lean manufacturing and we digitalize a lean system, you can imagine how efficient our processes or system would become. Those who do not know me, I'm Dominic Wangorocha. I'm a chemical engineer. I have a master's in chemical engineering, and I am current certified engineer. I have an MBA specializing in finance and investments. I'm an ISO lead auditor, a Six Sigma holder. I have 10 plus years in manufacturing. Today, we'll be looking at digital manufacturing. We'll be looking at Industry 4.0. We'll be looking at the smart factory, examples of digital manufacturing, the benefits of digital, and what challenges of digital manufacturing will be in developing countries. I think the better word will be emerging economies like Africa, South America, Asia, Pacific. How this would be very useful to us. For me, I think in a country like Nigeria, how well have we digitalized our processes, and how well have we improved our processes? Thinking computer, let's make it very simple, thinking computer. Digital manufacturing, when I say digital manufacturing, is the picture that you see, robots, many machines, I think this is what comes to the minds of many when we talk about digital manufacturing. Complexity, robots, people are going to lose their jobs. From this. So I want to simplify this. I want us to get to a point where we really want manufacturing. Digital manufacturing. What should you be thinking of more? You should be thinking of no more paper. I think this is positive. Think of connected stacks. I'll explain that as we go. Equipments can now talk to each other. Is this not positive? Generation of lots of data. Ease in the number of errors. I think for me, if we can get people to reduce the number of equipments that will help us reduce the number of people mistakes. For me, I think it's efficiency. People interface with equipment, equipment interface with equipment, and people consume from software. So I think this is what is super important. So let's look at what is digital. I say for me, growing up, I think digital for us was 0 and 1. We would remember binary. Getting information into that into a system using the 0 and the 1 for those digitalization. So the use of digital technologies to create value in a business model. Those digital technologies, bring them into the system to get to improve your processes and your system. And manufacturing, it's the transformation of raw materials into finished goods. Process there, transform it using labor, tools, chemicals, equipment, biological processes. For me, is what brings about manufacturing. Yeah, so how do we bring in digital into this so we could digital manufacturing? It's simple. That's why I have called digital manufacturing an integrated approach to manufacturing that is starting raw to finished goods, centered around computer systems. Digital technologies produce the finished goods. I get a raw material, I put in digital technologies, and I get a finished good. Digital manufacturing is all about. There are some technologies that are involved. 90% technologies. We look at autonomous robots, simulations, horizontal and vertical systems, Internet of Things, but this time, the industrial Internet of Things. We call it the IIoT, cybersecurity, which is super important because you don't want to digitalize your system and get it hacked. You need to invest in cybersecurity. Cloud, which is one of the most important technology. Yes, you get all of the big data. You should people to communicate with the equipment. You want people to communicate with the digital technologies. All of this generates data, and they get stored where? This is where we talk about big data, but they all get stored in the cloud. So the cloud system is super important that we have it. Additive manufacturing, augmented reality. Interestingly, I was opportunity one time to work in a plant where we used augmented reality, like a testing phase, and I saw how I could be here and wear those those glasses, and I could audit a plant somewhere in Tokyo, in Japan, or somewhere in Germany. And you get, so you see how the world becomes more unified, and how digital could just make the world easy, yes. Especially in a time like this, I can't travel to a neighboring country or outside the continent to perform a quality audit. But yes, I could get augmented reality and I could look through your plants and carry out my audit like I was there. So you see how the technologies just make life easy for us. There are other things that could help us, like other things I would say, those things that EDM evolved from the computer integrated manufacturing, which is designed for manufacturability, DFM, most importantly, lean manufacturing, because you want to make your systems more efficient and to take away waste, then you should be thinking digital. There are three dimensions to this. Product life cycle, we have the smart factory and the value chain management. We'll look at all of this. How do I make my products using digital manufacturing? How do I make my manufacturing unit smart? And how do I look through the value chain and get the best out of it? Yeah, I've written here that Industry 4.0 is where we are now. This session is not telling us about something we should be doing in the future. It's talking about something we should be doing now, or something we should have started doing. So when we go through this, I'm thinking more to how connected our systems interact with each other. How can we make them interact with each other? How do I get to my shop floor and the production operator who is operating the line, how do I make him not go to look for the SOP somewhere just to run his machine? How do I put like an augmented reality, like over his face, he has an eyeglass, that's the SOP is just right in front of him, he's reading the process steps for him. Oh, okay, that's too far. How do I have a QR code, put a QR code close to his machine that he can just scan and go to a particular page in the SOP just to continue what he's doing? This is what we should be thinking of. It's not rocket science. They're simple things. Creating a QR code it's not something that is impossible. So today, I don't have a complimentary card. What I have done is just create a QR code that when you come to me and say, oh, let me have your complimentary card on my phone, I'll show you my QR code. All the details about me, including my LinkedIn profile. So this is how we should be thinking. This is the future for us. So journey. What has the journey been? Because digital manufacturing today is in a space where we call the industry 4.0. Interestingly, I was in a session some days back and we were talking about 5.0. Like, we have not finished implementing industry 4.0 here in emerging markets, and we're talking about how do we get there now? Because the world is moving, and China has its own technology base, which they call China manufacturing setup or the manufacturing unit, which is just like the industry 4.0, but yes. Industry 4.0 actually started with the Germans and trying to digitalize their systems and looking at mechanization, how we moved from mechanization to mass production, and to today where we have digitalization. You ask me, so the 18th century, we're talking about steam power engines. That's where you have more of the quality control, before we started moving. In the 19th century, we were looking at the industry moved to you could not have a line which could produce so many things at the same time. And for quality, it went to inspection, control, assurance, coming in. And in the mid-20th century, we moved to Industry 3.0, where we had the ICTs, electronics, automation and network production. Yes, at this point, we started talking about SCADAs, HMIs, PLC systems. We had some software for quality management. We're networking already at this point. But today, what do we have? We have a more cyber physical system. We have IIoT, which is one of the most amazing technologies if you ask me, how a computer system can take all the data that I am producing at the moment and help me predict what can happen. We have more intelligent and flexible production system. We have artificial intelligence. We have machine learning, super for your predictive maintenance. And we have quality 4.0, which is continuous quality with real-time data and IIoT. So if you think of all of this, this is the journey. This is how the world has moved. What I tell people is there was always digitalization. So when we talk about these 9 technologies, it's not like they were never there, but how well have we fused it into into manufacturing? That's why digital manufacturing is. What's the digital factory for you? What do you think of? This is what I think of. I think of a time when we had the 3310 for those of us who. I think of a time where we now have the iPhone, smartphone. And we couldn't do so much with our manufacturing system. Time when it has been so upgraded, systems changed that we could do everything with our phone. I could send an email with my phone. I could place with my phone. I remember when I was married and I had to locate a village where where my in-laws were, and all we had to do was just share the pin through WhatsApp. The pin was shared, and all I had to do was click on the pin, and Google took me straight down there. So it's not a time where you'll be worried, oh, we've never been there, nobody from the family had been there. Technology has bridged that gap. These are the things that manufacturing, digital manufacturing is bridging with what you used to have. Think of it, for you to send an email in the past, you needed a postmaster. You needed a post office. Today, I send you an email in the next 3 seconds. I might not even need to send you an email. I just need to send you a WhatsApp of what I want. Most of us in manufacturing. Line 3 is down. It's down because we have this issue, that issue. The manager tells you, okay, please do this, or the engineering manager mentions, so I think it's go to the store and you get this O-ring and all. This is what digitalization is about. So I'm trying to simplify this so that we don't make it so ambiguous that we don't want to implement. So we should think of the age before smartphone and today's phone. This is the age before digitalization in manufacturing. And we are having digitalization, so manufacturing should actually change. So the prominent enablers for me is IoT, robotics, cyber physical systems, big data, artificial intelligence, machine learning, if you ask me. But what are the key elements of a smart factory? Intelligent machines. When I say intelligent machines, I'm talking about machines that can be upgraded. So we don't want a system that we cannot digitalize, advanced analytics and the people at work. We need their skills to be upgraded. We're not taking people out of work. We're going to upgrade them to the point where they can do so much with what they know. And before we had people on the lines clicking them, we could have a room with computers and people operating the factory from their computer system. I visited the factory, I think, in at one point in my career, and we had just one man in the factory going around, but we had people sitting in the offices who were operating the whole plant from when raw materials are dosed, the material to the filling line, to when they are shipped to the truck. No human being. The only thing the human being does is imputes the digits. The zeros and the ones to make this happen. robots do the rest of the works, or data are collected to help understand what should be done. So the technologies, the 9 technologies I think we've spoken about, we'll speak about them in a little bit more detail. So I've picked some of them that I think it will be interesting to understand better or to know more of. But it's something that's important. Like, you need to understand this part. Your equipment, you have equipment, right? Good. You have PLCs, HMI, SCADA, you have the MES system. Think of production like this. You have all of this, good, super. You have ERP, right? This is where you are now. Or you have a cloud-based system. You really want to move to this point. Think of what? You should be thinking about IIoT, the industrial internet. Think of big data. Why do I want us to think about this? Because we will need machine learning. And machine learning will translate into data, and to help us with things like predictive maintenance. All of this we need to think of. Yeah, let's talk about IIoT, which is one very interesting technology. When it's what enables what. So you remember at the beginning of this session, this lecture, talked about how people could communicate to humans could communicate to humans, and this could in turn communicate to the people back, and we share that. So this is where IoT comes in play, where machines and computers are communicating their intelligent industrial operations using advanced digital analytics for transformation of their businesses. This is all IoT does. So one of the greatest benefits of IoT has been seen as the reduction of human errors. And I'll give you an example. I have a system today that breaks down every 5 days. It's been happening for the longest time, but yeah, of course, not a problem, because we always have someone who fixes it. When I implement an industrial Internet of Things that could capture this, and capture why it breaks down, I'm already learning. So you get machine learning is already taking place. It's understanding a machine better. And it tells me, oh, before the 5th day, when a particular part of this machine is going to get worn out, we'll change that part of the machine. It doesn't just save us the breakdown, right? It saves us time, it saves us effort also, but there's something very important that this saves us. When next I'm buying a machine, I know better how to specify, how to make my specification for the kind of machine that I want to buy. I don't know if you really picture this, but these are the advantages of having a digitalized system. And these are the areas where it helps us. You can see it helps also in quality control and maintenance. How do I want to run my always going to pick a sample on the line when they produce, because I want to check this pH. I have a system in place online that constantly checks the pH at the same time that I require it. So it's all about this. So of course, I put this picture here because there's also an Internet of Things when it comes to consumers. So that it doesn't look like a far concept for us. We have Internet of Things when it comes to consumers, like phones, which we explained earlier, the TVs. You see, the phone connects to what we wear, the smartwatch. So a very good example, I go out on my run every morning, and I run 10 kilometers. But every day, it tells me how well I ran my 10 kilometers. It compares it, and it's able to tell me why I did better. And I'm able to look at this data, and I said, there are days when I'm not running better because maybe I didn't rest better the day before, and I understand the dynamics. So this is Internet of Things when it comes to consumers, and how like using the phone and the smartwatch example, it's the same thing when we come to machinery. When you look at Internet of Things from manufacturing point of view, what are those things that you could collect the data, analyze them, understand better why they are happening, so that you could propose better solutions to the manufacturing system. An example of IIoT, I looked at the BASF plants. What they have done is the use of the radio identification, like RFIDs, wireless networks, to their plants. So one interesting thing that they have done here in the manufacturing of customized shampoos and liquid soap is the customer will input what he wants. We'll look at this later when we talk about mass customization. The customer inputs what he wants as a sample, And these tags 20 bottles on the assembly line, and you communicate to the production machine what kind of soap that he wants. I give you a very good example. I have that product. I have the customer specification here on a tag with an RFID. And you put that tag here as it goes through the line. When it gets to the filling nozzle, it creates the blend that this particular product needs because it's a customized blend. This is what the world is moving into. So you can also, let's bring it closer home. So I have an RFID on this product. Why? Because I want while it goes through the line, everything concerning this product when it comes to weight, when it comes to the fuel volume, when it comes to the product weight, the packaging weight, when it comes to chemical analysis for the particular content, I want to have it. I want to know it. I want it for individual items. Okay, no, I want it for items that are produced at so hours. You can get all of this data. You no longer want sampling to be done by human beings when they are able to come to the line. You want it to be done for particular products. Oh, machine 223. Push out every 10th bottle. Push out every 100th bottle. Once you get to the line, those bottles are taken out and labeled, and you take those bottles to where they are analyzed. So you already have a detailed understanding or a sample of everything that is required. So when you think of IoT and where it can be applied, it's everywhere. This is what makes it very important and super. Intelligence is one other thing. So see it as Dominic, yes. You have Dominic, who is a quality manager, a digital manufacturing expert, and you want a machine to think the way I think. You want a machine to be able to handle production the way I handle production. So it's just to make the machine learn the things that I do or the way that I do them. And you have the machine think like me, behave like me when it comes to manufacturing. This is what happens. So you have intelligence, yes, an engineering guy who is very good at fixing challenges or fixing problems. Oh, I want to mirror the way he does it. So we have an artificial intelligent machine who will do the same and produce same data. This is why artificial intelligence is really growing, because it's also used in robotics. One very good area where we see the use is in areas like washing machines, where they're able to mimic or model the way we wash and wash the same way and produce similar results. So machine learning, super important. I've explained this previously, and how it applies to us. Very important when you look at it from maintenance POV, but also when you look at it from the line, like the production. So you have a quality manager. Oh, why are we always having a misaligned label on this line? Happening at this time, like we did have this yesterday. You could have a system that learns the process or understands it. Then we understand, oh, it's when we have these particular bottles that we have misalignments. Or it's when we have this particular operator that we have misalignments. Or it's when we're running at this time of the day, the relative humidity is high, we have temperature high. But this is what machine learning does for us. It takes all of these things and analyzes them using the algorithm that it has in place. Yesterday, I was looking at artificial intelligence and machine learning, and we could have two types. We could have a supervised learning and an unsupervised learning. And we use this to teach the equipments on how to respond to problem solving also. So these are areas that are super important. What are those examples of digital manufacturing? And what are those areas that we think we can see them? I talked about visual work instructions. How could you digitalize SOPs? Actually, today, you have SOPs pasted almost everywhere, even on equipments. There's only a risk of, this is a safety risk. You could have fire start from there. So how do you want to digitalize this? And give you a very good example. I said QR code. Just get a card or an RFID, just get a tag that has a QR code, put it on that machine, paste it on that machine, and the operator can come scan it. And when he scans, all he sees is production SOPs. It's a whole lot, right? Good. All he does is search liquid filling machine, and the SOP pops out on his phone. Or if you have a tablet on that line, super good. When you have things like that, you're reducing paper, one, and then you can speak sustainability. You're reducing paper, but you also make it very fast for him to get to the SOP, because all he has to do is search. He also could search a particular spot or the challenge that he's currently having on the machine. You could just search misaligned labels, or you just search what to do when you have oil spill, and straight he goes there and he follows the process and he solves the problem. Training, I cannot overemphasize. One of the ways digital technologies are helping us is something like this, where you could be anywhere in the world and you could train your staffs. They could be on the shop floor and you just have visual demos showing them what to do at different points of time, and awareness and all of that. Audits, I explained earlier how augmented reality has been a source of joy for me, because today I audit factories without going anywhere. I can sit where I am and I just use augmented reality and audit the factory. And I bring up my report, because I'll be seeing exactly what I would have seen if I was there. Yeah, maybe it will take me a longer time because I'm getting used to it. But yes, I'm able to visit every part of the site. But more interestingly, places I would not have been able to visit because maybe I was tired while I was doing my tours. But do this, I'm just moving my head around, I'm waving my joystick, and I'm seeing everything that I need to see. It also helps us in machine monitoring and maintenance and job tracking visibility, where you could have a trend of OE. We produce 300 cases this hour, it pops up. Before the hour, every 30 minutes, you have the data, every 10 minutes, you know what you're producing per minute, and you have this trend, you have your OE, you understand why this is happening. So this is one other area I think is very important for operations or production. I think one of the places where we could see this is for some robotics, like a pallet. I've seen this being used and it really saves time. It's not just this is on a pallet or helping you palletize. There are also systems that help you put the product into the cases or into the ship. Interestingly, one of the advantages of this is that you don't have situations where you have missing shrinks like we have today, or missing bottles, or missing tablets in your packs. Because it is an intelligent system and it has been trained through machine learning and by supervised training or unsupervised, you will see it becomes more efficient to do things like this. So we discussed, I say using IoT so I look at a factory somewhere in Houston. I am sitting in as like a director of manufacturing, and I want to know what's happening in my factory in Houston. What I need to do is go here, click Houston, and see my data for Houston. Okay, I want a particular machine in Houston, not just click Houston. I got in department, I click it, I want to understand there. And I want to say, okay, what's the OE for Houston factory? All in clicks, you want to break that down more and you see the graph. So these are the interesting things when it comes to IoT, when it comes to anywhere in the world, you could have all of this. Raw material issuance, the same thing. You could have racks fitted with level sensors, weight sensors, so that when anything is taken out of the rack, you already have the weights or the quantities in your. It tells you the number that you have left in the system. It triggers if it's below the stock level, like reorder level, it gets to reorder level. It triggers the manufacturer, the warehouse manager, which in turn triggers the procurement manager for a reorder. Seamless. You don't need to get your we have just run out of caustic, we need to run, we need to get caustic. No, You have range sensors, you have RFIDs that will transmit this information every time you take out of the tank, the bulk tank was caustic. It gives you the value, you understand what the shortage could be or what the order level is, and it triggers procurement to make an order. Simple. It's just interesting and an amazing what digital manufacturing could be for us. Digital predictive maintenance, like I explained earlier, system for me, like I always say, is the most important part where all of those information comes here, right? Super. So if you have your equipment working, you have data being collected all the time, and you have times where you have breakdown and it's taking that data, check brake shoe wear, you have wear and tear, or I give you a regular example, in soap manufacturing, you have consistent wear out of your sieves. But yeah, because of predictive maintenance with the help of machine learning and data analytics, you know when this always happens. So it already tells you, oh, how long a sieve can last. So automatically, you already know when you should replace. Or maybe I should get something better that would last longer. So, but this is what predictive maintenance is. It's all about collection of data, learning, and knowing how to implement. Of course, we have been through the cycle where we have moved from we just maintain when we have breakdown to we have a preventive maintenance plan, which is risk-based, but it is time to learn, let your machine learn from your machine so that you can predict when the failure will happen. And if you can predict the nights before it happens, I'm going to change that part. I don't want a shutdown. So immediately that shift is, we're having a shift changeover. I'm changing the particular part that will break down in the next shift, or when I have that room and people are on break. You don't have those losses that you should have. So this, for me, are the advantages of having a digital, in this, of having a digital manufacturing when it comes to example. It says the hydraulic press, you already have a problem here. But you see, it's because it's always IoT is collecting all the data. You know when you had this challenge, what time, what happened before you had that challenge. All of this is what helps you to when you should plan for a change. Quality management, we cannot overemphasize as much as, yes, this is a major area of interest. It's also a part where, again, this is where I'm doing my projecting, how we could improve inspection today. This area, when we look at the things that we could change, yes, we could put online processes that does the monitoring. We have systems where like change control can be digitalized. Like you don't need to, processes cannot happen unless a change document is raised. So yeah, it's automatic. You want to build a new product. It gets to the point where initiate project, and product is not, you're not able to initiate project because it's asking you raise change control, It's simple. You get it. You are digitalizing the system. You're making people follow the process unless they won't be able to. Or you're about to start up the machine and it's you choose machine to start and it's asking you perform line clearance, and you see that perform line clearance, perform line clearance, perform line clearance. These are the simple ways of which we can digitalize our systems after use of notepads, and how can we have our the plenty documents that we use for imputing weights, pH, label errors and all of that. How can we convert those into in our notepads? How can we impute them just there on the line into computer systems? Why do we want to do this? So we can easily trend, we can easily see what is happening and make corrections. For me, this is what is important when we are looking at digital industry 4.0, quality 4.0. This is one area that is super important. I want to emphasize the cyber physical. Bringing all of this together, the Internet of Things is bringing the sensors, the communicators. So the information we get from the sensors, from the environment, from the communicators, from actuators, we'll bring all of this to the processor. We exchange this data and we use it to get results that are required for our systems. So how well do we do this? How well can we improve systems using this? I talked about mass customization. Yes, so areas like 3D printing. So today, if you want to order a sneakers, where you want it, how you want it, you can do that today. You go to the Nike site, you put all of the information, so you get the sneakers just for yourself. Why is this? How has this become possible? Industry 4.0 is digital manufacturing. It's build, like you can be the manufacturer of your own product. You just need to fill in the details that you want, and the equipment there, which is intelligent, will build exactly what you. The same way we can see this in shipping and logistics, where barcodes on pallets can be scanned, and I saw something super exciting in the factory. And the equipment, like if one moves to the pallet that was just produced, it scans the barcode, and it takes it to the warehouse scans it, sends it an information of which truck. So you have trucks at different locations, and this motorized pallet truck takes it straight to the truck that requires that product. How easy. Like you don't need the noise, you don't need 1 million people doing this. You just need information being transmitted from people on their systems to these equipments, and from equipment to equipment. Remember, the pallet truck spoke to the warehouse, the door, the entrance of the warehouse. Okay, this is where you should take it to, and all of that. This is the interesting things about digital research and development. Super virtual reality is doing a lot, making products. From where you are, I think we already see this in health, where doctors can actually be doing this in your house. You are not even there, and like it's being made. These things are happening, so it's very possible. But yes, I'll still remind us that we should think of the simple how we can do this. The simpler ways, not very big ways. How small can you start? Can you start with just check digitalizing them? I think it's the best place to start. We'll see better ways to do this. offer. It's mixed about flexibility, it brings lead times, customer demands. Remember, we talked about mass customization. It brings about new offerings of downstream services, So there's so many things it has to offer for us. I think above all, it increases our knowledge capability, taking us from where we used to be to where we are currently. So if you ask me, I think it's good for business because data availability is there. No more data keepers, no more lengthy morning meetings, because you already have a dashboard of all the information. You don't need a lengthy morning meeting. We're coming to discuss the whys, because now the dashboard already shows us the areas where there are challenges, and we're just coming to discuss why those challenges are happening, what we could do better to improve our systems. Smart workers will be needed. What are the challenges for us in developing countries or emerging I think for us, a skill set, scalability. Yeah, we will need people who know more of this. My push here, or my advice here is more people in manufacturing who are doing machine learning, who are courses, artificial intelligence courses, IIoT courses. We need to scale up. We need to learn more. And yes, over weeks of risk in months to come, I'll be doing some of these trainings for us in manufacturing, more in the 9 technologies, and how we could improve ourselves and how we could apply some of these things. Funding is also very important, which is, yes, I know it requires money to get this, but yes, we need to do the cost benefit ratio. Then we'll be able to say, okay, this is why I think implementing DM in your company will be super important and useful. With artificial intelligence, like I said, machine learning, collaborations. I was talking with the director at Oracle some days back, and we're looking at how could we even train people pro bono, get them skilled to understand more about digital manufacturing. Yeah, so how do we chart your way there? First of all, you need to create awareness. You need people to know, you need to educate them, you need to identify the gaps. You take action into gaining agility for this. It starts from, like review your current environment and digital strategy, identify the weaknesses. How are you currently collecting data, storing them? You need to know, how do you want your company to operate? What are you looking at for your business? You want to continue working the way you are working today? What really is this success? What small things do you need to do to digitalize that will take? These are the things we should be thinking. I have some examples of augmented reality, but we can look at that some other session. This is my charge to us. Digitalize something today. You digitalize today. What can you do differently today? What's the system that you can transform? Is it maintenance you can transform? Is it SOPs? Ask me the first thing, I think she utilizes your SOPs. Utilize your SOPs, utilize your checklist on the line, utilize your safety procedures, utilize your safety systems. I think these are areas where we need to digitalize. Then from this, we'll grow into doing more. I'll continue doing more of this. Also ask people to share their thoughts and areas where they have digitalized the system and how we could learn from those systems or how we could learn from those processes. And yes, of course, we'll get the best out of it. So I want to thank you very much for joining the session today. Please subscribe to my YouTube account. It's just Dominic Wangwaracha. Maybe one day to be Dominic Wangwaracha TV, but just subscribe. And when I have new lessons or new learnings, I would share here.